g'day, flatties and globe defenders. It's Critical Think from Down Under. Recently, I had a discussion with Travis from The Plain Truth, and I've picked out a couple of things I wanted to talk about, and I've had an objective look at a couple of things there and gone and done my own measurements and observations, and I'm going to present some of that here today. I'm going to start with this little bit at the beginning of the discussion because it represents a great example of the Dunning-Kruger effect.
Yeah, one of the things that I find that I guess I would say is disingenuous is that the question that I put to you was, is there anything that makes sense on just a basic level? And I think that if someone says no, there's nothing that makes sense about someone saying that the Earth is flat. To me, I think that that's just a completely, absolutely dishonest response because...
Because what? Because flat Earth makes sense to you? Certainly doesn't make sense to me, and I'm going to be perfectly honest about it and say that it doesn't make any sense. Now, that's only dishonest in your eyes, but that's because you are mistaken. You are mistaken about a lot of things. The flat Earth is silly, and I'm being totally honest when I say that.
The simplicity of the argument, even if there's disagreement in terms of the conclusion, the argument is very simple.
Is very simple, like it looks flat to me. That's about as simple as it gets. After that, there's nothing flat Earth has to offer. You got to understand that one of the very first flat Earth videos I watched was this one, and this is pretty laughable. This is ridiculous. This is mind-numbingly stupid. It represents the typical flat earther that has no understanding of the physical universe, physical laws, and how the globe actually works. So, yeah, that's stupid.
Logical. It's very straightforward. I feel like a lot of the activity that I've had with streams and channels is that those opponents that I interact with, to me, it seems like they just do not want to consider the alternative.
As far as globers are concerned, that couldn't be any further from the truth, and that's an accurate description of your average flat earther. They have no interest. A flat earther has completely no interest in examining the evidence that may point to the Earth not being flat. They so strongly believe that the Earth is flat, and like the plain truth here as well, they believe that there is no evidence which could prove otherwise, and therefore they don't need to look at it.
For whatever it's worth, to me, I think that that's dishonest. I've said it before, and I'll just reiterate it here. I would rather someone like you say, yeah, Travis, what you're saying totally makes sense.
But I'm not going to lie to you, Travis. What you are saying is a load of bollocks. And that's me being honest. If I were to try and stroke your ego and sugarcoat it for you, to me that would be dishonest. But I'm telling you now, it's a load of bollocks.
I hear what you're saying. That makes absolute sense, but I disagree because of X, Y, and Z. I have more respect, and I haven't actually had anybody say that yet.
Well, of course nobody's going to say that yet, because you dish out a load of bollocks.
I have more respect for that response than absolutely not. There is nothing. There is absolutely... When I hear ballers say there is absolutely no evidence for flat Earth, I absolutely know that they are just incapable of looking at anything objectively.
Okay, so apparently globers are incapable of looking at anything objectively. Yet we do much of this. Flat earthers do none. Let's just listen to a few snippets.
My claims that I make do not depend on my giving you measurements to the horizon or to the distant shoreline, because I'm not claiming that there's physical obstruction due to Earth curve. I don't need to measure anything.
So he doesn't need to measure anything. He doesn't need to take a critical look at anything. He doesn't need to look objectively. How can you look objectively if you don't need to measure anything?
I'm not making a claim that requires me to measure anything.
Of course you are.
The Earth doesn't have a shape.
I got a question for you. What in that mirage? I mean that's very small, but when it's bigger, is that air or water? What do you say it is?
It's the air. That's
Show
right.
me how this particular ship, the bottom of it is disappeared. Show me how that works. Exactly how that works.
You can't. Yeah, so what I'm going to do right now is offer you a proof that this house here is three-dimensionally a different size than this house over here. This house over here is magnified, and it's distorted more than this house over here. But this house and this house are both shot from the same location, same focal length. The only thing that's changed, and including that, look at the antenna here at the top left. You see how long this antenna is right here?
So he's claiming that the house on the left is magnified compared to the house on the right, and that antenna is long compared to the one on the left. Well, let's look at this objectively, shall we? So I've taken these two pictures and I've overlaid them. One need to be rotated a little bit to make it line up. Okay, first let's look at the antenna at the top left. And as we fade in and out, you can see one is not longer than the other one. They are pretty much exactly the same if you go from the treetop. It's just that one is more blurry than the other one, and so it doesn't stand out. So there's something that you might be wrong about there, Travis. Would you be willing to admit that you were perhaps wrong about that? And now let's have a look when we fade the house in and out. Yes, it's a lot blurrier, which because of the atmospheric conditions, but I'd hardly say that the blurry one is magnified. I think combined with that little bit of blurriness and the extension of the reflection due to the refraction there, with the vertical gradient changing there's a bit of a temperature gradient causing that, I would say. But I wouldn't call that magnified at all. I mean, this lines up pretty good. So all I've done is just shifted that over a little bit, rotated it a bit. Everything seems to line up pretty good. Even the waterline. So I'm not really sure what that's supposed to represent. It represents a normal place. It could be a round or a flat Earth, but certainly illustrates the vertical density gradient rather than a horizontal one.
Line of sight. This water line is not curvature. The water line is produced by the inferior mirage. That inferior mirage covers, stretches into our proximity over 3D space, so that wherever this line is, wherever this water line is, from that water line to the ship, everything behind that inferior mirage is blocked by the inferior mirage, which includes more water as well as the hull of the ship. And if there was someone in a small little dinghy boat or whatever out here, you wouldn't be able to see him. Not because he's over a curve, but because he's behind the refraction.
I'm going to disagree with that, and I've got the evidence to prove it. If there's a boat behind that, and I've got a picture of this, it will be behind the curve, and that inferior mirage does not represent air, but we'll carry on. We'll see a little bit later.
I've got a question for you. What in that mirage, I mean that's very small, but when it's bigger, is that air or water? What do you say it is?
It's the air.
Okay, so he says it's the air, and yet he has in his own videos, he has things like, well, there's a boat. What's that boat floating on? Is that floating on air or floating on water? And this boat, is that floating on air or is that floating on water? So he says that the inferior mirage hides the water. Well, he may be right about that one thing. There's the water there right underneath the inferior mirage, but it's certainly not made of air, that inferior mirage. Maybe the top, half a metre, maybe, if you're lucky. So let's take an objective look at what happens when there's a curved surface or a flat surface. Now we have here a 2.7 kilometre long bridge. Goes from Brighton to Clontarf Beach, and it's flat for 2.4 kilometres and a couple of curves at the end. And this is good to take some observations on a known flat surface, quite a long one, at 2.4 kilometres of flat surface with some curves to make the comparison. So here we're at one end and you can clearly see that there is a curve. So let's watch what happens with this cyclist. Right, so the cyclist goes over the curve and he's disappearing bottom up. Now here's a long shot down the flat piece. You can see all the way down, this is 2.4 kilometres thereabouts, you can see it curve away at the end. But until that, it's pretty much flat. And you can also see there is an inferior mirage. Now is that inferior mirage water? No. Is it air? No. That's just solid concrete. It's not air. And we've got a little bit of a video. Now I'm going to zoom out here and you can see it. Get a better picture of how far away these people are. And here's another long shot. You can clearly see the inferior mirage. Makes it look like a pool of water. But this is what happens when you get very close to a surface. Any surface, especially a surface that is heated in with respect to the air above it. The light reaches a critical angle which causes total internal reflection there. And the light, instead of being absorbed by the surface, is actually bounced off. So that's how this particular mirage gets formed. And if there's a layer of hot air there, that's going to cause the light to refract off as well. So is there water there? No. Is there air there? No. That's concrete. Here's some very amazing thing. If you look at the wall on the right, there's another mirage against the wall on the right. Now that is again a concrete wall. But there, let's play this and you can see several things in this video. First of all, I can see the feet of everybody right down to the end. And if you watch this person here, they start to disappear bottom up. Why is that? Well, it's because they've gone to the other side. And you see the reflection here. Now this is quite amazing because there is this distortion right at that surface boundary, and that where the light is stretched there and it's reflected off the side. This is pretty amazing stuff. Does that mean that this here on the right here is air because there's an inferior mirage there? No, it doesn't mean that. There's actually concrete there. You can't say that you'd be able to see the cars on the other side of the concrete if that inferior mirage wasn't there. The inferior mirage is not hiding the cars on the other side of the concrete. It's the inferior mirage is hiding the concrete. The same down here. These people are not floating in the air. They're actually still standing or running or riding on concrete. So you remember the coin on the table trick where Flatty show that a coin disappears from bottom up because they've got the camera below the edge of the table. Now this bridge has a stretch that's 2.4 kilometres long. It's much longer than your average couple of feet table, yet I can still see the bottom of things. It's because my camera is not lowered to be below the surface. So this height of the camera here is about 300 millimetres over 2.4 metres. That represents a very same angle as 1.5 metres in height observed over 12 kilometres. And you know what that's going to look like over the ocean? It's going to look like that. Do we see that here? No, we don't. So there's a still picture. You can still see all the attributes of inferior mirage onto the right surface as well as onto the bottom surface. But that's not air, that's the bridge made of concrete. If you look carefully at this still picture I've taken out of the video, there is a person there. You can only see their head. And why is that? Well, it's because they've gone over the curve. That's why you can only see their head. Not because of this inferior mirage. There's actually concrete there, remember. Now I've drawn in the line there, the mirror line, so, you know, that we often see drawn in over the ocean. And let's look at this objectively now and say, well, below this mirror line between this here and here, do you think that would be air? It certainly doesn't look like that. And this mirror line here, between there and there, do you think that would be air? I don't think so. There's a bridge there, and there's a bridge there. So look at this person here. There's a lot of them missing, and it's because they're over the curve. Now here's another section of concrete. There's concrete blocks that people can sit on or not, and there's spaces in between the concrete ends, and then there's a space where there's possibly a place that you can sit, and then the concrete blocks start again. Now this is at Darling Harbour in Sydney. Have a look at what happens to this bird. Did you see that? I'll just go back again. There, look at that reflection of that bird, and that's concrete. The bird is miraging off the concrete. Here's another picture. So you don't just get mirages horizontally, you get them vertically as well. So they can happen on any surface, flat or curved. So here's a question for everyone about, you know, there's a bird, there's an inferior mirage there, and the head and beak of this bird is missing. So the questionnaire, the quiz is, why is the front of the bird missing? And here are the options for the answer. A, it is beyond the vanishing line. B, the angular resolution of the beak is less than the Rayleigh criterion. C, it is vanished by the ether band. D, it disappears into its own reflection. Or E, you can't see through concrete. So have a think about that and choose your answer, and we'll see how you go. Okay, if you answered E, you can't see through concrete, then you'd be correct. If you've answered any of the other things, then you're probably a flat earther who doesn't understand physics and the way light behaves. Okay, let's go on to another example. So, why is the bottom of this cyclist missing? Is it because of A, refraction, or B, the vanishing line at the surface there, or C, as you lower the camera the angle gets smaller, or D, the compression on the horizon that's formed there by that line on the concrete, or E, you can't see through concrete. Now think about that and think about what your answer might be, and let's see. Again, it's E, you can't see through concrete. So again, flatties, if you've answered any of the above, it's clear you don't understand the mechanics of light, the physics, and how concrete might work. So I've got one final quiz for you, and this one is why can't you see the bottom of this ship? And is the answer A, it is beyond the vanishing line, or B, because of the angle of attack, or C, refraction and or compression, or D, it's vanished by the invisible ether band, because there is no evidence of any ether band, inferior mirage, superior mirage, general atmospheric distortions. There's no evidence of that there. So that's why I've said invisible ether band. Or perhaps E, you can't see through the ocean. So you can put your answers in the comments below and we'll see who gets it right. Well, thanks for watching. Now this video represents many hours of work for me. It's gathering data, researching and putting the pieces together into a congruent presentation. And if you like what you see, please like and subscribe and spread the word. Thank you.